So let's start. Let's start. Well, this week we are going to talk about Cmake. Well, Cmake is, you might ask, like, what is Cmake? Well, Cmake is our last approach, okay? But I will come from a general term and then I narrow it down to Cmake so you can have an understanding what is Cmake, why we are going to talk about it. So it's okay. I'm going to talk from general stuff and then narrow it down to Cmake. The contents that you're going to learn in this tutorial would be, at first, I'm going to define, as I said, the general terms. I'm going to define the terms compiling something or building something. You might already know about compiling and building, and you might even use it as the same thing, but as you are now programmers and you have started programming, you definitely know what is these terms, at least you have heard of it. And then I will talk about automatic build and what does automatic build means. And then I will go to why we need it. And then I will go to Cmake as an automatic build method. And then I will talk about details of Cmake. So we are going from a general thing that what is building and compiling, and then automatic way of them, and then why we need some tool to make it automatic, and then to Cmake. Okay. So before everything, I will start this with a question. Does building a software means compiling it? You know, building and compiling, sometimes between some people, even you have heard that people use this word like they are one word or like they are synonyms, but they are not actually. For example, you have a code, someone might ask you build your software, or someone ask you compile your source, but technically they are different. Well, build is very more general term, and it's more than just compiling. What are these? I will explain to you. As I said, build is very general term. It means the variety of tasks, from editing your source material to creating scripts to do testing to connecting everything together. So in a way that the output is a product, like a software that you can give to your customer. So you know building has several steps, like pre-processing, compiling, linking, and so on. Let me talk about compiling as something simple. You already know, for example, when you have a source code, like let's say you have a source code in C++, and then you compile it, and compile will change it to a machine program, right? So this is compiling. But building a software means like a series of tasks, which even includes compiling, like pre-processing, as I said, compiling your sources and linking your sources together. I will talk about all of them. Converting data and what so on, and even testing your software, even packaging your software. For example, when you have a software, usually it have an install file, right? Like you put next, install. Even this called packaging, even packaging your software from the source is part of building a software. So just I want you to know that compiling is very specific. It's just transferring your code to the output that a machine can run, right? So it's like translating, very simple, translating a source code, you compile it, and then machine can run it as a software. But for building, we have, as I said, I want just in short form, say it again in short form, that all the tasks that you have to do before releasing your software, compiling, packaging, testing, and whatsoever. So, and compiling, as I said, it's just simply translating code to machine code. So I can say then compiling is a subset of building. It means just a part of building is compiling. You might ask why should we do this? But let me show you with a real life example. You definitely saw, let's say, you definitely saw source codes, and I think now you, as you are reading C sharp, you have a source code, then you compile it. But let me show you real life project. For example, I want to show you, let's say, a game source code, which is in GitHub. It's called mine test, for example. Let me find it. Okay. I just want to show you what is the real software looks like. You usually have a source code, which is one file, and then you have it like compile it to one software. But in real life, projects are really big. You see how many folders exist here? And this is the source code. Let
Sir,
me,
we cannot see.
what?
We
You,
can't see.
you cannot see? Sorry. Now you are seeing. Do you see anything?
No.
Okay, sorry. I think the sharing problem, I wish you could have told it. Thank you for reminding me. Let me do it again. Sorry. Uh, okay, do you see it now?
Yes.
Okay, so let me go back. I was doing presenting actually, and I wrote everything. But since this time, instead of let's say Microsoft Teams, I was using web version. This problem happened. Sorry. I think you didn't saw the first three slides. Well, as I said, I talked about Cmake and I talked about contents that I'm going to talk about building and compiling and why we need automatic build, what is Cmake and introduction of Cmake. Then I talked about you as you heard it, that when we are building something, it means I just fast forward everything I said because you already hear it. Building uh, means like packaging your software, linking your software, and do all the tasks that uh, that creates a software for you that you can ship it to customer. But compiling is just changing your source file to one output. Okay. And I was here that you told me kindly that you don't see it. And thank you once again. So, to make it short, building is a combination of compiling, packaging, testing, and everything. And compiling is just translating your source code to machine code. That's it. I wanted to show you a real life software. Usually when you have a, definitely you already did some programmings, right? You saw a source code, right? And let's say it's a calculator, and then you compile it to a like a machine code that you can run, right? But in real life, real projects are not just one file that you compile it and you will get an output. Okay? So in real life, projects consist many files together. Let me show you here. I show you this is a game engine on GitHub, which is open source. That's why you can see the source. I already introduced you GitHub. I want you to show you a real project and how it looks like. You see, here you see a source, and these are the files. You see, this file, for example, collision CPPs, cloudparam.h, and content. You see many files. So think about it. In real life, you don't have just one source. You have many sources that should have linked together, should have worked together. That's why building is really important. That's why maybe for your like simple task, when you are going to make a calculator, you don't need to build, you just compile everything. But when you have big projects, you have to build your software. You compile all of them, then you connect all of them, then you test them, and then you release them, right? So I only wanted to show you a real project that consists many files together. So now, as you already see, when you have many files, it's really difficult to compile each of them separately and then connect them separately. So it would be very, like, it would be time consuming so much to connect everything together, and you might make a mistake and like something not connecting to something and crash the whole project. That's why we are, like in real projects, people are using some things called build automation system. So what is build automation system? You already see we have a problem here in big projects that there are many files. So build automation, it means that we will make some script, or we make we use some kind of tool, that this tool will help us to automatically build all the files together, to automatically compile all of them, automatically package all of them, automatically test all of them, and link all of them. So as I said, because in real life, we will have a difficult task to put everything together and to compile everything, we will use automatic build to make things easier, right? And what a build automation system do for you? It download all the dependencies. For example, you use a library. I will explain about them. A library or something that needs something else to be run. So it will automatically download it for you. It will compile the source into binary file. It will package it for you. It will run the test, and it will deploy it for you. Okay. So the aim is, I want you to know enough that we want to make the building process automatically. When we need to build, when we need to use automatic build systems, okay? So, in small projects, you usually don't need such a thing. You do everything manually. Why? Because you have only one, two, three files, and you want to compile them. But in larger projects, as I showed you, uh, it's really difficult to keep tracks of all files, all folders, and everything. And using, like, when you want to know when you should use an automatic build system, for example, you don't want to do hard coding paths, you and your package need to be sent on different computers. You have your projects should work on different, let's say, operating systems. Instead of these, let me talk about it very simpler. You see, you have a game, and this game is available on Android and available on iOS and available on Windows, right? So as you see, the platforms, in this case, Windows, Mac OS, or whatsoever, are different. And the software you are using on there to build your software are different, right? So we need a tool that help us to send our project, to build our project automatically suitable for different platforms. So as you see in big projects, like you have a software, let's say Telegram, WhatsApp, it is available on Windows, on, I don't know, Android, Linux, and everything. So if you don't want to use automatic build system, you have to build it once in Android, once in iOS, once on Mac, and whatsoever. But when you use automatic build, you make a script, and the rest for different platforms will be automatically made for you. Now you know why we need such a things, right? And there are many tools that you can use for these purposes. One of them is Cmake, which is one of the best. You know, there are some auto build tools. One of them are GNU Make, which is for Linux, Auto Tools. I don't know the famous one, Ninja, Maven, or Fast Build, and Cmake. So Cmake is one of the best. Why? Because every IDE, you already know IDE, supports CMake. For example, if you are using Visual Studio, if you are using CLion, if you are using a VS Codium or whatsoever. And it has a really nice scripting that can define rules for you. You will see them later. So as you see, there is a chart that this is time and this is output of the Google search. You see, during the time, the CMake interest of people and programmers went higher. It means CMake is the best option and is the most demanding option as an auto tool for building softwares. So that's why we have chosen CMake for you to know. As you see, it has like really high gap to the other competitors. Okay, then now let's talk a bit about CMake itself. Cmake is open source cross-platform. For those of you who don't know what is cross-platform, cross-platform is something is available on all the operating system, Windows, Linux, Mac OS, or whatsoever. And it is a tool that designed, I already told you, for building, testing, packaging your software. It will control software compilation process for you, and it will make it's compiler independent. It means you can use it on different compilers. Okay, and basically it's not going to build your project for you, but it's going to build the configuration file for you, and the building software will use this configuration to build your software. I understand now it might be a bit confusing for you, but that's why I'm going to show it to you in both Windows and Linux, just live. And the thing is, sometimes for small projects, you don't have to use CMake. But as I say, in big projects, when your project is really complex, and I told you it has many, many, many different source files, like here, you see, like here, it's really difficult to follow everything. And I think even this project is using CMake as well. You see some CMake config file, okay? So actually, CMake is a building automation tool, which I already told you. How can Cmake help you? It allows you to build your software. It allows you to test your software. It allows you to package your software. It's open source. It supports Microsoft Visual Studio, which I know you are using. It supports Xcode if you are, let's say, a Mac OS developer. It supports Make. It creates Makefile if you are a Linux developer. And many of the IDEs have it pre-installed on their own. I will show you later. Okay, let's say how to install Cmake. There are different ways. You can use, for example, if you are using Mac OS, in your command line, it's enough to write brew install Cmake. If you are using Linux, you can use your package manager to install Cmake. Or even if you are using Visual Studio or Android Studio or CLion, it's already predefined there. But I will show you the manual way. You simply go to Cmake org, and there is a section called download, and you will find the version you want. Here are the source, but you don't go for the source. Go for binary section. And for Windows, just install it, just download it and install it. That's it, as simple. So for using Cmake, you have to install it from cmake.org. and install the binary for Windows, or as I already told you, how to work with it in Linux and Mac OS as well. So now I will show you how to work with Cmake, how to config Cmake. Basically, Cmake has a one file that you put all the configuration in that file. Okay, so it basically tells Cmake how you want to configure your build process. And it inside this file, remember, this file should be always fixed. It's always Cmake, even it should be Cm capital and Ake, and L should be capital .txt, just like that. And inside that, you write some, let's say, some configuration that shows how you want to configure your Cmake. Since I know you haven't come to these subjects like until now, I will stop it here and I will show you in real. And then I will show you a simple program, a hello world program, and then we will continue. So let's continue. Let's make a project. I will create a folder and let's call it Cmake or YouTube Cmake. Okay, I will go inside. And here I can create some projects. For example, let's say you already know what C and C++ a bit at least. I want to write a hello world program in C++. So I will create a main.cpp. And what would be the content? Let's open it. Okay. I will write first include and IO stream. Yeah. And just I will write main function. Very simple. I will keep it simple. And I will just steady see out. As you know, this comment is used for printing stuff. Hello, YouTube, and like that, and /n to go for the next line. So that would be it. And I will put like a cin to not to close the command line and wait for our character to be set. Okay, cin, that's get, I wrote it right, and return 0. So pretty simple. It's only, the rule is just printing hello YouTube and get a character and then go out. I'm going to save it. So we have it here. And then I make my Cmake file. Okay, so you can compile your C++ file, but I want to create a configuration file because the aim of this lesson is to work with Cmake. So it should be Cm capital lists. Remember, it should be S. .txt. And I will open it. Okay. It's a Cmake file. Inside this, we should write our configuration. I will show you a very, very basic one. First, I will write Cmake minimum required. What does it say actually? It says on the system that you're going to run, it should be a Cmake at least version, let's say one of the versions of Cmake, for example, 3.0. Okay, so it means at least a Cmake with this version should be installed. And name of my project, I will call it like project and hello world. It could be any name you want. And then
Sir,
what?
sorry, sir.
Hmm?
the versions of the Cmake
Mhm.
and find them in the internet. Like we have to know all specific versions
Okay.
of Cmake.
Okay, very good questions. I wanted to show you later, but there are different ways you can do this. For example, later I will run this for you, but I will run it now. For example, uh, if you run Cmake and you have installed it, you run Cmake GUI. Let me put it. Wait, I will. You know, this is I run CMake on. I will show it to you on Windows as well. I installed a Windows on my computer as well. I will show it on, but it's something like that. And if you go to Help and if you go to About, it shows the last version of the CMake which is installed on your software. It's 3.17 dots, something like that, right? So here you can see it, and uh, here, as you see, as I told you, when you go to download, here you can see the versions of the CMake, which is the last version you are using as well. Because some comments might be supported in, for example, version CMake version 3 and not version 2, right? And you are using version 3. So you want to make sure that your CMake configuration is working. That's why you put a version that you are sure that, for example, the version you are working, that the softwares, for example, if you put this configuration in other computer, it will work. And if for example, the person on that computer doesn't have this CMake, he or she will get an error and he will understand, okay, I should update it, right? Was I clear?
Thank you, sir.
You're welcome. Okay. Uh, okay, I will continue it and I will show you. Okay, now I want to say I have an output. And for this, there's a comment called add executable. I will show it to you on the rest of presentation, but I put it now here because I want you to know basically what is this, because it's pretty new. And then I will put a name, hello world, uh, name of my project, and the file that my project is inside. What is that? Main.cpp, right? Main.cpp. And that's it. That's it. It's very simple now. And let me save it. So it's minimum required project. And so you understand here, you put a name, and at the end it should be your source files, okay? And uh, and watch out that CMake use space as a delimiter. It's something that you have to put between these two. So I'm going to save it. Okay, now I'm close it. Uh, and let's do something as a review. Let's put these on a repository in Git, right? Because I want you to remember the previous week as well. So let me go to GitHub and create an empty repository. I will put it like Cmake test. So that's it. Create a repository. And I will copy it. So that's it. Here, let me send it to Git. How would I do that? I would put, first of all, let me clone something. Wait, let me create a folder here. Cmake it, and here I put open terminal and I put git clone. Okay, it says you have empty repository. I will say it's okay. And I'm going to copy my code here. This is not about Cmake. I just want you to get familiar with Git more than usual. So now I'm going to put these files in my Git, and I will use like Git push uh, header branch. Sorry. Mm, okay. Well, I don't want to deal with it now. I don't put it on. I don't put. Let's switch back to our previous style, which is here. Okay, I don't put it in Git now because now there's a problem. Maybe because I'm using some kind of VPN. Uh, but I just wanted to get familiar with Git. But it's okay. So by now you know you have a source file and you have a configuration file here. Okay. And as you ask questions, I am running, I will run Cmake GUI here. I will show it to you on Windows as well. You know, it has two parts, very simple. It says where is your source file and where to build binaries, right? So where is your source file, where is to build binaries. My source file is in this folder. I put it here. You can browse it, right? Let it be open. But I just copy paste the path, and then I will put the path here. And I want my build file to be at build name of the folder. Just at the end of this path, I will put like build Linux, right? Very simple. And it has only two buttons here. One is configure, which it says, do you want to create this build Linux? Because you don't have it here. I say, okay, no problem. And here, something will pop up. It says for what platforms you want to do this. As I said, it's a cross-platform. It can generate files for different platforms. And I say Unix make file because now I'm using Linux. And I put finish, and you wait a bit for it to detect your files. Wait. You see, it finds I have the compiler C. Just give it a time. Give it a time. It's finding everything. Okay, now it's done. Let me make it this way. Configuration has been done. So I have put configure, right? And then I will put generate, means, okay, you have configure file. If you have an error, you will see here. And then I will put generate. Generating is done as well. So let's repeat it again. I made a configuration file, then I opened Cmake, I put source here, and I said where my file is going to be built, and then I configured it and generated it. Okay, I can now close it. You see here, you see different files that Cmake are made for me. Make files are something in Linux that you can compile your files with. There are auto-compile, let's say, systems in Linux. I will show it to you exactly the very project in Windows as well. And it has some folders. You see, it's all created everything for me, like hello world, these things that if I wanted to build it manually, it would be really difficult. Okay, and how to use Makefile? Now, by now, my software hasn't been made yet. I will go to my build folder, sorry, which is this, and run my Makefile. As I said, this is for Linux. In Linux, you only simply press make, and it starts to build your project. It says, see, building your source code to an object, and then linking everything hello world, and build your target hello world. You see, now my software is made here. Let's test it. I will put in Linux, it's simple, like hello world. You see, hello YouTube, and I had to put enter. It's done now, right? Okay. Let me close it. Okay, now I want to do something, and I want to use this project exactly in Windows as well. I have installed a VirtualBox in my computer with Linux with Windows installed, and I'm going to show it on Windows as well. You see, it was UTB Cmake, and I link my hard drive to be shared between these VirtualBox and but you don't need it. Let's say you have a Windows and you have a colleague that worked with Linux and send the files to you as a software developer in Windows. Let me hide it here. Okay, it's not hiding. Okay. This is Windows, as you see. And what was our file? It was UTB Cmake, right? And you see, our config files are here as well. On Windows, I recommend you to use Notepad++, because Notepad++ has auto-completion for your Cmake file. It means, for example, when you write Cmake, you see, you have these autocomplete things. You don't have to remember everything by word by word. So you can use Notepad++, and let's try it on Windows. I run Cmake, which is here. My Cmake is here on Windows. You see, only the appearance is different because Windows is white and so on. And your question, you said how to know the version, exactly the same. About, this is the same version, right? I will use the source file, which is here. You can browse it as well, but I just put it here. Okay. And then I will put it here. But instead, this time, I will write, for example, build at Windows, right? And I will clear my cache. So everything from the previous time will be removed. Okay, it's okay. So I have source, I have build folders, which this time I specified it's Windows. Again, the same process. So let's do it. Configure. Yes. Now you see on Windows, it says which platform you want to work. It has like Ninja and Kate, everything. And you have to, for example, if you have Visual Studio installed on your computer, Visual Studio will come here as well. So I was assuming that you are going to use Visual Studio. That's why I have installed it as well. So I choose Visual Studio, and you let the other things to be default, and then finish. And when it's stopped, it means it's doing some work. It's finding my C compiler, finding Microsoft Visual Studio, and wait for it to be done. Okay, done, right? And then I will put generate, exactly the same. Generating done. Let me refresh it here. You see, build Windows is done as well. So with one configuration file, I have output on Windows and Linux. But let's test it on Windows as well, because I'm assuming that you're using Windows. You see, it makes automatically many files for me, many different things for me. So in Visual Studio, so we have a solution files, which is like our project. So my file was hello world, and I find hello world.sln. It's written here. It's Visual Studio solution. So I will run it, and I can have my output in Visual Studio as easy as you see. So with one configuration, I had my file on Linux, I had make files, and I have generated. So professional companies actually works like that. Like they have different version for different platforms. They are not like just one source file and one output. Okay, now let's try it on Windows as well. On Windows, on solution bar, I assuming that you know Visual Studio because you have to be working with it by now. I chose this Hello World as my startup project. Now it's my startup project. And now I am build it here. What is this build? It is exactly equivalent when I put here and I wrote make files. You see, on Linux, I put make. Here, you right click. As I said, first set up as a startup project, then right click and build it. and let the Windows to build it for you. So let's see. It's making me okay, okay, I'm doing this, I'm doing that. I was like, okay, okay, okay. So build to success. So it means like now our project should be work. Let me run it and we will see. My Windows might be a bit slow because it's on virtual machine. So you see this hello world exe, hello YouTube. You see, hello YouTube, and I will press enter. That's it. And you can hear, you can see your source file, which is here, main file, main.cpp. You see here. Even you can see when you open it, your Cmake file here. And you see, you can even change your Cmake file as well if you wish, right? So you can open it. So as you see, with one configuration, I had output both on Windows and Linux. And let me refresh it here. You see, my hello world here is exe file, which is for Windows, and on Linux, it's just binary file. So as you see, that's how this is very simple. Of course, professional companies don't work with hello world, but I just wanted to show you like this is the professional way that you can configure some kind of auto build for different platforms. Even it can be even Mac OS, right? As simple. So let's go back to our presentation. Even you can do it with command line, but I don't want to make it complicated for you. You simply can use Cmake graphic file when you install it, which is the most simple way. So just simple it as you see. Okay, let's go and see. So basically, Cmake has a language. As you already see the Cmake file, for example, I use this command like add executable was the name and the source file. There are some other commands you can use. For example, set. Set actually sets a variable with some value. For example, if I set foo bar, then we have a variable called bar, and sorry, we have a variable called foo, and the inside foo will be bar. And if I say if foo, it checks if foo exists or no. If so, as I said, I can set foo bar, I can say foo number and whatsoever. So set will set a variable with some information inside. If you use unset, it's obvious. It's opposite of this command. It will remove this from your variable. It can be even lists and also variables. For example, here, if you want to uh, put a variable, you use let me make it simpler. Variables in Cmake are shown like this, with a dollar sign and a curly bracket open and curly bracket close. It means it shows Cmake that this is a variable, I mean, not the actual letters of BAR, but the variable. But you will see it in example as well. I also put the link for documentation. You can see documentation online on the very website that you have downloaded Cmake. Also, for example, I don't want to talk about this comment, but I want to just show you. Comments can have arguments. Like, for example, file, it can be used for reading and writing. And you can put like something like a function, like write file content, read file variable. I don't want to talk about it. I just want you that things can have arguments inside. Also in Cmake, you can have if, else if, else, and if, for each, while, and while, break, continue, return, and things like that. Even you can put comments in your code. Like later, I will show you later. Like you will see that, here I have done this, here I have done that. With this number sign, or let's say hash sign, the rest will be like a comment. Also, it has include, which can include another Cmake file inside your file. I just want to show you, not to talk about them now. Add subdirectory will add another directory in your project. What does it mean? Like this, for example, your project has many directories. You put one Cmake file for each of the content here. You see, here there is one Cmake. And if I go back to another folder, let's say scripts, there might be another Cmake here, as you see. So I want you to understand it. That's why I show you examples. So uh, creating a Cmake project, I already showed you a basic one. So our entry port is cmake.list.txt, which you already see, right? You put it in your project root. What do I mean by that? It means the thing that we did here, that a Cmake file is our project root file, it means like in the project file. And we can have Cmake files in the subdirectories, but it's for bigger projects. For small projects, we don't need to have different subdirectories, but you already saw a big project as well. And try to keep it simple, okay? Let's repeat again the structure. You put, it's necessary, Cmake minimum required version x.y. You already know it can be 2.9, 3.1, and whatsoever. You put a project name. You can have sometimes an option, but you don't always use that. For example, there is a secret feature in your source code. You can here like enable it, disable it, but you usually don't. Add executable. It means I want output with this name, hello world, which you already saw, from this source. In our case was main.cpp. Here it could be whatsoever, hello.cpp. Add subdirectory. As I said, when projects are big, for example, you sometimes in a project, you have a library. You have another file inside the project. You define them in different folders and make a C file in that folder. You already see on the example on GitHub I showed you. And you create a Cmake file for that folder as well. With this, you tell Cmake that, aha, I have another folder and I have a Cmake inside that folder. Don't forget it. So, right? So this actually tells your Cmake. Let me dive more inside the tools. For example, add executable. It can even have some options. It can be Windows, like you can put some arguments that generate outputs according to your will. For example, I want Windows, I want Mac OS bundle, I want Linux file, and different sources to be compiled together. You already saw it, but it has different options to do. And also, for example, add library. Sometimes you want to create a library. I will tell you about libraries later. You definitely in your like while working with computers, you see, for example, some files called in Windows DLL, let's say, some files called .lib. These are libraries. Definitely many of you already know about them, but I want to, for those of you who doesn't know, it's all right. So libraries, all those DLL files are their lib files. And what are the usage? Usage is there are some codes inside library that your program using them, right? So it's like a book you are having while you are going to university, and sometimes you need a question, you go inside and find your answer. So libraries are just like that. Sometimes I can create a custom target. Target means like the output file you want to create. Don't be afraid. It's just like exe file, library, whatsoever. I don't go deep about this one, but I will create a library here in our today class to show you. Libraries can be static, shared, like even its interface. It's completely understandable. You don't know the difference, but I will tell you later in next slide. Okay, Libraries, I already told you, libraries are files that your project using them inside itself. Okay? And in Windows, for example, libraries can be shared in all the platforms actually. But in Windows, shared libraries are DLL files. In Linux are .so files. In Mac OS are called dvlib. So if you use Cmake, now you are getting to know why it's like useful. With one configuration, if you run it on Windows, as we did, it generates Windows related file. If you run it on Linux, it will generate Linux related files, and so on. And static files, you can have even static libraries as well, and shared libraries. The difference is when you use a static library, your static is like the name is obvious. It means like when your code want to use it, it use all the codes inside the library and attach it to the program, and then program will use it. But when something is shared, it only uses at the demand when only your program needs that file, go and finds that part, that area inside the library. But when you are using a static library, when you are compiling it, all of the code will attach to your executable file. And so it's only important that you know shared libraries and static libraries. So as I said, static, all the code will attach to your executable file. And these are not like for our class, like the difference between shared and static. It's for programming. I'm just saying it for those of you who don't know. Interface, I don't want to go deep into this one because it's for virtual one. It's when you get more advanced. I just put it here so you know there is such a thing. And it actually doesn't create any library. It's used for header files. You will understand it later. But for now, I want you to know that you have shared library and static libraries. Uh, okay, and while creating a target, and I say target is like could be a library, could be executable file, and so on. Sometimes you have to use different files to create your output. As I said, libraries, like your software use different libraries. So you have to include all the directories to your Cmake configuration file. So it give access to your file that, okay, see, you have other files, you can use them. You have other files, you can use them. So it's some kind of include directory. It's some kind of comment that these comments makes your target, or let's say your output, to use different include files. It's completely understandable. I don't want you to like know all the details now, but you will become familiar, and then you will know it when you need it. You can have even some compile definitions. For example, when you compile a file on command line, you put, for example, sometimes compile -d-s. Here you can put that definitions inside your configuration file as well. You can have some kind of compile option as well. For example, sometimes you want to see all the warnings. You put some flags that shows you all the warnings. These are not necessary, but now it's important for you to know the core. Then you will use them later. For example, here you see, I have a source file, which is, let's say, main.cpp. And it uses some libraries. This command will tell Cmake that this source file needs these libraries, okay? Needs these libraries, so it will give access to it. You will see the creating library later. I understand now it might be a bit confusing. And sometimes when you are creating a library, let's say you have a library that your software is using, okay? You have to, when you are compiling your code, you have to attach the library to your code. So what do I mean by attach? I already told you that libraries are some codes that your software needs. So it will attach those part of codes to your software. So you will use them with link libraries, means linking libraries to your executable file like that. For example, you have a file which is my.exe, and it needs this library which I already created it. So it will link this library to my.exe, okay? And as so on. It can be private, public, and like programming, that a class can be private and public. I don't go to these details, but I will show you an example. Uh, you see, I will practically make an example for you, but I just want you to know the structure. You see, for example, this is my Cmake file, and inside my Cmake file, I will create a library. I will call it my library, and this library is a combination of these files, which is, for example, mylib.h, mylib.cpp, and header file. And then I link them together, and I define my include file if they are in different directory as well. It's completely you will see them in the example how to create a library. Okay, now I will show you how to create a library as well. Let's go to our example here. Okay, uh, I'm going to delete this too, right? So now we had a like hello we had a hello world app with Cmake file. I want to make this code in a way that it uses libraries, so you can understand how it would be the library. First of all, do you know what is header files in C++? Do you know? Can someone answer?
No, sir.
Okay, okay. It's okay. It's not actually part of our CMake class, but I will show you. You know, uh, I will tell it to you with an example. So this file actually is saying hello, right? I want to to let's say divide this code to different codes, which you understand how a software can use different sources to run. Let's see it, how it would be. So I create a file and I call it header file, and I call it, let's say mm, let's say hello would be simple. Hello.h or HPP, no difference. Okay, I will put HPP for C++. HPP is extension for header files in C++. I will create it. Okay, I think, let me open it. Okay, yeah. So this is a header file for C++, and then I need another file, and I call it hello.cpp. Okay, these are now empty. Okay, I want to move this part, which prints hello, uh, to my library. So instead of my software showing this, my library has this code and it uses the library. So let's change the file. So uh, okay, at first I'm going to edit this file. I will write if def these are C++ parts. So let me see. Hello, that it's include part def define. Yes. Hello. Okay. Uh, I will. In header file. Sorry, it is C++ file. I should write it in header file. I will copy paste it here. Okay. I should write it again. I will write if I will explain what I'm doing, but this is, as I said, this is about C++, not our Cmake class. Define hello. Okay. You know, in a header file, you tell just the name of the functions which you are going to implement. So it is like, it's like, for example, you tell the compiler, I want to create this function, but how to create it, you will create it in different file. I just want to create a function which prints hello world, right? So I will say hello void. I will call it, say, hello, for example. Yes. Usually functions should have a kind of, let's say, uh, implementation, right? But here you just name the function in header. You don't have to implement it here. Okay, I just put a name and then end if. This part is always fixed when you are defining header file, but it changed according to your name of the file. And here I only just say I have a function which is going to print hello, right? But I didn't tell the compiler how it's going to print hello. I will do it in another file, which is implementation of this. This was header, you see .hpp, and now I'm going to write how it's going to be. I would like include, just like a C++ program, IO stream. Yeah, that's it. And this file is going to use what? Hello.h. Why? Because the name, the declaration of the file is in a header file. So basically header files is just showing what functions you have and but how these functions is going to work, you define it in C++ files. Headers are placed just for names, just for introduction. So I said I have a file, a function called hello. If you remember, it was say hello, right? So let me open it together so you see it better. See, in hello HPP, I said I have this function, and here I want to implement that function. Okay, let's implement it. I will write. So it means inside the functions I have to write. I will write cd cout and hello. Exactly what we were doing. You can bear with this like this. So you see, what did I do? Here I said in header file, which is HPP, I have this function, but I didn't say how this function works. Here I say this function, which I said here, should be work like this. Let me save them. And now let's change our C++ file, main file as well. So I want to tell my main file to use header file. Include, what should it use? Hello.hpp. So it means now my function have the access to the functions which is written here, which is this. Okay, let me remove things here. Okay. And now, what was the name of function? I would say hello. So that's it. You see, what did I do actually? Now I said let's saw it in reverse way. I have a function which is in this file, and it's going to say hello. What we were doing like in one file, I want to do it in library style. And in a header file, I said I'm going to have such a function. And then I implement this function here. And you have to include the header here as well. Okay. So basically, we shift what was here to here. Okay. Now let's see how our Cmake file will change now. Okay. This is our Cmake file. Okay. Here we don't have to change anything. Here, for example, you can put let's change it for you. UTB S, let's say. Okay. Now, but here, see, now I want to create a library. All these purpose was for that, right? And you by now you understand the concept of library, which is using different files inside your file. I will use add library. Okay. And I will put it here. And my library's name would be say hello, let's say. Okay. And it's going to be static. But you will see we can have the default thing is static. So if I don't put a static, it's static as well. But I will put it. Okay. Static. And what files are going to be linked in this library? This header file and this file. Okay, let's do it. Hello.hpp and hello.cpp. So what? Sorry. Hello.cpp. And I close it. That's it. So I'm telling that I'm going to create a library, which the library name would be this is the name of the library I'm going to put. It's called say hello, and it will using these type of files. Okay, now let's add executable. Okay. For executable, for example, I can just put a name here. Let's put it the name of our project here, UTB class, for example, and our main file, right? Main.cpp. So it means like we are going to have a file names UTB class, and it's going to use this file. So by now, we create a library, you see here, and we are creating our output the same we were doing. But we didn't connect this library to this file, right? Because now they don't, we say, okay, library exists, exe file exists, but we want to connect them together. How? One of the comments I showed you, it's called target link libraries. This, okay? And would be UTB class. And yeah, would be UTB class. And wait, sorry. Yeah, and I want it to be private. And you will understand the concept of this later as well. And which you see, this is the name of the file which is going to create. I'm going to say this file which is going to be create, connect this with the library which I just named. I named it here. Okay. So let's name it here. That's it. So let's review it. Cmake Minion require the project name library is going, static library is going to use this header file and this implementation file, and our executable file is going to be UTB class from this main source file. And then I want to say link this output with this library. Remember, the name here should be exactly here. Okay, save all. Now let's see what will be happened. I will run and the same process you saw. Let me put it here, nicer. Yeah. And let me remove every cache. Okay. Here, and I say BLD lib. BLD lib, or let's make it simpler. Lib Linux. Now let's configure it. So you want to create it? Yeah, I want to create it. On Linux, you can choose, yeah, I Linux. And let's configure it. So configuration done. And let's generate it. Oh, yeah, generation done as well. Okay, so now I can close it. And you see, here it's created and make files are here. Okay, let's build it in Linux. I will show you in Windows as well. As I said, Linux simple, make. It says you made a simple file, you made the error hello.h. Okay, I will put, I think I should have, instead of HPP, you see, I made the error. I put like say H. Let me fix it. One of, I think here I made a mistake. Let's make it HPP, but here shouldn't be problem. Here, see, this was my problem, type problem. Sorry about it. Let's make sure that here, so here it's CPP, here CPP, HPP, HPP, HPP. So yeah, now everything should be fine. Let me remove it. You see, the problem was, let me again, do it again. I will put it, I will copy it here, then remove the cache, yeah, and build Linux lib. Generate, yeah, I want to, yeah, done, and generate done. Okay, hope this time it's okay. Make, here, make. I'm getting an error with, see, I think I have some mistake here. So you see, you sometimes you are having an error. It says here, oh, another typo. You see, I have put one quotation here. Let me, these are just sometimes happens. You see, that was sometimes in your files, you see errors like that. Let me do the make again. Okay, say hello. It says in line 6 in main.cpp. Okay. Sorry, wait a moment. So say hello is here. Say hello is here. say hello is here. So, oh, maybe I should remake it. Let me. Don't worry, these things sometimes happens, especially when you are compiling things on Linux. Linux. Okay, let's go here. Make maybe still some errors. It says it's not declared in the sorry. Probably I put some kind of typo mistake here. I think I did it before here in manual. Let me compare it here. And here. So it's pretty the same. Let me delete it here. Okay. Oh, well, probably some typo is here, but let me remove it. Let me put it static to make it like our project again. Static, and so it's as you say, it's pretty the same. And I save it all. You see, I have a hello CPP here, and as you see, it's hello CPP. It's our header file. As you see, the same header, hello CPP, main file. I think I forgot this return on that project, but no problem. I will try to do it from the scratch. You see, our it is pretty the same. And let me run it again on Cmake. Here, clear the cache. Yes. Here, manual, Linux lib generated. I will do them fast. Okay, and generate. Okay, Linux lib is here. We have our make files, and I put make. Our project is make now, and but you see here, a library is made, and our software, which is Cmake test, is using this library. How? Using like that Cmake test. If I put it, it's working. It says hello, right? So it was. You see, so this is my main file, and now I remember what was the mistake here. You see here, I should put this include here only this file, and here in what was the name? Here I was putting it as well in my main file as well. So okay, you see our file is made, and we have a library now. This .a in Linux is a library which is static. Okay, let's make it shared library instead of static. If I put instead of static, I would put shared. Okay, now save it. Now let's run make again. Okay, here You see, it was the static one. And now I have a shared library in Linux r.so files. Maybe it's a bit weird for you. I will go on Windows and do all the process the same again. Let's switch to Windows and find our project. This is our project. This is CPP file. It says here another program is using it. Wait, let me then let me exit from the Linux. I am go here, close. You see here in the very configuration file exists. And wait, this is the configuration file. To remember it again, minimum required, the name of project. We are using a library, but now I want to make a static library on Windows at first. So make it static. And this, so we are linking files together. Now we are going to work on Windows. So let's see. This is our file. At first, again, we repeat, we want to create a static library on Windows. So I change it on static. So nothing is changing actually between Linux and Windows. And now I will run Cmake. I will delete the cache, and I will copy this path here. And here, and name a folder like winlib, let's say. And now continue the process. Configure for Visual Studio. Yeah, Visual Studio. So wait. It's detecting, it shows, for example, detecting on your operating system, this. And sometimes it takes a bit. Find C compiler, okay. First time you do configuration, it's usually takes time, but it's done. And then generating done. Okay. Here, let me refresh it. See, we have a winlib. Let me close it. I am running winlib, and in Linux, in Windows, I told you already, your project is a solution file, .sln. So let me open it, and we will try to create a library. Takes time to run. Okay. First time on Windows that you're running Visual Studio, it's usually a heavy software and takes time rather than Linux. Wait, okay, yes, import it. Even if it was Mac OS, that would be no difference. So for those of you who have Mac OS, you can have one configuration file for Windows, Linux, Mac OS, sometimes Android, and so on. So prepare it. Okay, finally. Now you see why I don't like Windows much. So slow, right? Okay. My program here, the thing that I was running. Let me show it to you. I name it Cmake test here. because I continue with this file, Cmake test, but it can be whatsoever. And it's now here. Okay, so the name that you are putting here. First of all, I told you, you put it as a startup project, and then you build it. So let's build it. Running, testing. So built successfully. Okay, let's check our, first of all, let's run it. Then I will show you other stuff. I'm going to run it. It simply will print a hello for me. You see, hello. So, but the hello, you see, this is hello. But let's check it again. The hello is not on my main file. Actually, my main file is using say hello inside this file. And this file now is changed to a library for me, these three, these two. You see, these two now changed to a library. What was the name of library? I said, say hello. Let's find it in our project. So in Windows, if I go to debug, you see, this is my software. It's not software, but just let's say Cmake test, which is writing a hello. And this lib is a static library in Windows. On Linux, it was .a. On Windows, it's .lib and other things that is needed. Let's now change it to a dynamic library so you can see a DLL file. So we are creating a DLL file now. I will go to the source file and find the Cmake. I'm telling you here now, it would be one of your tasks, but that would be good to know. You know, as I said, in Linux, when we want to make a shared library, we just change it to share, right? Okay. And but in Windows, there is a limitation that if you want to export DLL, you had to set something that Windows let us to export DLLs. It's pretty simple. You just simply put Cmake minimum. You set something. Let's say set, and we will put Cmake and Windows. Export all symbols. Yeah, so if you put this, you can export shared libraries in Windows. Else, you cannot. In Linux, you don't need such a thing. Now, let's build our project again, and we will see if it creates a DLL file for us as well. So it's doing the, okay, successful. Okay, now let's run it again. Yes. You see, hello. Okay, let me close it. And I will go to my folder, which is manual. And I will go to Windows, debug, where, you see, this is my code. And it creates a DLL file called say hello DLL. So in Windows, as you see, you can create a dynamic library as well. In Linux, you can, and whatsoever. Even I already prepared some other examples for you, which I will put them on Moodle. And let me show you on Windows. It would be slow. Sorry. I will put them on Moodle so you can try. And I put it here, Cmake examples. some basic examples you can go and see. And for example, let me see. If for example, it's like a hello CMake, hello header, or a static library, a shared library. Let's check these and let's see what's the difference here between our project and others. I'm going to open it. Okay. So this is a CMake. I clicked so many times. Okay. You see, it's still the same. CMake minimum required, project name, add a library. Hello library, for example, static. But here, you see the difference between this. First of all, it doesn't use header file, but I wanted you to learn what is header. And it uses this file, but you see, this is a src/this, because here our source have been put here on src. So you have to put the specific path as well from your CMake file. Your CMake file is here, and your code is on the folder of the src. So that's why it's put here. And target include directory. The header file here is put it on include. That's why we have to use this comment as this comment and line as well. See here, static hello.h is here, but you don't have to be worried. I just want to show you, and it can configure differently. For example, add executable file again, src main. You see, I just wanted to show you that sometimes your source file is not exactly where your CMake file is, when your project especially is big. So you have to sometimes put a path as well. Let's explore something else. I just want to show you. Let's say, for example, sometimes, you see, the CMake file is pretty simple, right? But we have this at subdirectory. It shows we have directories, which each of these directory has a CMake for its own. So let's see other directories. You see, these have its own CMake file as well. And this CMake says, okay, compile it like that and use this project like that. And this CMake, I don't want to explain like all of them to you because it takes like time. But I just want to show you that sometimes when your project is big, when your project is small, you don't have to use this. When your project is big and you have to have different folders, you put CMake files in each folder. Okay. For now, for me, it's enough for you to be able to create use Cmake as simple as possible, like this, or create a library. And sometimes you don't need a library, even it would be simpler. Yeah, like you don't even need these, right? So it could be simple, but then you grow it up, grow it up, grow it up. So that's for Cmake. I will put some some examples on Moodle. And then I will show something like an assignment for you. You will see them by night, some assignment that you can try and then send me the result. I know CMake sometimes can be difficult to handle at the beginning, but just try. Even if you have problem, you can see the other examples, which I will put a folder with many examples for you. You can try, you can search online, you can ask me, and whatsoever. So I just want you to get familiar. Why I want you to do this, because on your final project, you have to use, for example, Cmake. You have to use Git, like a kind of repository on your own. You can use Git or SVN. I don't care, but just you have to have a repository. Like you have to create a Git folder and like this, for example, if we want, for example, if I want to make it Git, I would put like Git init and a Git folder came here, and so I just want to tell you it's not difficult, but I want you to use git add and then git commit dash m, for example, done, something like that, right? Okay. Because it's long because it has many files here, many files here, but it's all fine. So uh, that's it for today. And thank you for your patience. And sorry that my computer hanged because I wanted you to be able to see the actual power of Cmake. That actually the aim is to make you able to work on Linux and Windows and Mac and whatsoever. So I installed the Windows for this class to run the Visual Studio, which I know you are being taught as well, and that's why it was heavy on my computer and restart, unfortunately. But finally, hopefully we had managed it. So if you have any questions, I'm here to listen.
No, thank you, sir. It was all clear.
Thank you, thank you.
Thank you, sir.
Thank you for your patience,
Thank
and you're welcome. And as always, if you have any question, you can simply email me, and uh, I will try to help. Okay.
Okay, so we appreciate it. Thank you so much.
You're very welcome. And okay, have a nice, let's say, evening and enjoy the rest of the day.
You too. Have a stunning day.
Thank you, sir.
Thank you. See you soon. Bye.
See you.
Bye.
Bye.